All right, lesson 1.6, part 2, starts us with example 2. It says use a graphing utility to explore the transformations f of x equals x squared by graphing f of x, f of 2x, and f of 1/2 x on the axes below. Explain the transformations. All right, so we start out with f of x equals x squared. And so we can use our calculator. I'm just going to use tables since you can't see my calculator on here. So we know that f of x equals x squared had a parent table, and I'm going to add in the -3 because my graph is big enough that we can see that, and it'll help us see some of it better, okay? So I'm going to do -3 to 3, and so it's 9, 4, 1, 0, 1, 4, and 9. And so I can graph that, or we could actually do -4. So -4 would be 16, +4 would also be 16. That way we can see the full thing here. All right, so there's a graph of f of x equals x squared. So let's look at f of 2x. I'm going to let that be our g of x, okay? So g of x is going to be equal to f of 2x. Well, remember, if f of x is x squared, then f of 2x, excuse me, it's just going to be 2x squared. And so when we look at it like this, we know that 2 is inside with the x, so it's going to be horizontal. And it's being multiplied, so we know it's going to be a stretch or a shrink. Now remember, when you multiply by 2, stuff gets bigger, but x does the opposite, so it's going to be a shrink. And it's actually going to be by the reciprocal 1/2. Okay, it's by the reciprocal of the number. And so we could make a table here. And we say, okay, well, we know our x's are going to be divided by 2. And so if I take all my x's and I divide by 2, starting with the -4, all the way to the +4, I get these x values, and then my y values are going to stay the same. Oh, I forgot the 16. I was like, I'm off somewhere. And so we could graph those. Now remember, we said it's going to be a horizontal shrink. So think about that. Shrink something from the left and the right horizontally. I push it in, it's going to make it more narrow. And so we can already see that with those end points there. Those top points, it's already in more. So we know it's going to be more narrow. Oh, what happened? Oh, that point was off. Let me back up here. Go in there and move that point where it goes. I misgraphed it. All right, so we can see that graph did get more narrow. Now, we could have also said, well, wait, 2x squared is 2x times 2x, which is 4x squared, which if I look at it like that, that would have meant it's going to be a vertical stretch by 4. It's going to look the same. Your table's going to be a little different because then this would mean y times 4. So I would have kept those original x's the same. But I'd have multiplied those y's by 4. So obviously couldn't have put that point on there, or this one, But there's that negative 216 that we had in the other one, okay? And so, yeah, if you look, this point is in the other table, this one, and that one. So it would have given us more points that were bigger, but we'd have got the same exact graph. All right, so let's look at the last one there, f of 1/2 x. I'm just going to call that h of x. So if h of x is equal to f of 1/2 x, that means where we have x, we're going to plug in 1/2 x. So I got 1/2 x squared. Now, if I stop here, that's going to be inside, so we know it's going to be a horizontal. I'm going to have to write it below it here. It's being multiplied, so it's a stretch or a shrink. Remember, normally when you multiply by 1/2, stuff gets smaller, but x does the opposite. Therefore, it's going to be a stretch by, and because it's x, it's going to be the reciprocal of 1/2, which is 2. And so we could do this with our table. So we would divide our x's by 1/2, but dividing by 1/2 is the same as multiplying by 2. And so using my original table there, if I multiply my x's by 2, oops, I don't have room for that last one, so I'm just going to leave it off. And then my y's would stay the same. And then I can plot those points. Well, I can't fit the first one on there, but I can fit the others. And so we can see here that this is making our graph wider. I had to use the wrong numbers again on that one side. Darn it. Sorry, guys. All right. Here we go. That's why you always look at your graph. Make sure it looks right. Mine was lopsided, so it told me I did something wrong, and I looked over at the wrong table when I pulled my x values. So there's our graph for that. Now also, though, because it is 1/2 x squared, we could have said, well, 1/2 x times 1/2 x is 1/4 x squared, which would have made this a vertical shrink by 1/4. And if I was going to use that in my table, that would just be y times 1/4. And if you work that out, you'll see that some of our points do match up. All right, moving on to the next one. Example 3. It says the graph of y equals f of x can be drawn by connecting the points in the table below with line segments. In the grid at the right, we're going to graph f of x, and then the graph of h of x equals -2 f of x minus 3 plus 4. Describe the transformations that are performed on y equals f of x to obtain the graph of h of x. And then complete the table and graph h of x on the same coordinate grid. Okay, so here's the table that they gave us. So what they're doing here is they're setting this up. This is our original, okay? This next column here, so, well, sorry, I was pointing using the computer, but you can't see it. So let me tell you this. All right, so here's our original. We're going to have to graph them. These next two columns are just work area so that we can build our new table, okay? They're going to write them, though, as ordered pairs, but if you wanted to, you could make this your table for your transformation. Or you can write them as ordered pairs, whichever, okay? So, but this is just the work to give us those x values, and this is a place to work to give us the y values. All right, so I'm going to go back up here to the top so that I can see my graph. All right, so we're going to graph those ordered pairs, so you're going to have to look at your paper while I do this here. All right, so my first ordered pair is -4, -2. Then we have -2, 3. We have negative 1, 0, 1, 4, and 4, 2. And so we're going to connect those points in that order. So there's my original one, okay? So now, though, it tells us for the transformation one, we're going to use this. Now, don't worry that it has the F in it, okay? That just meant that we didn't have, like, a parent function to be able to use on this one. It's not an x squared. It's not a square root of x or a cube root of x, okay? So we had to create our own. But don't worry about it. What's on the outside is still going to affect the y. What's on the inside is going to affect the x. And the f is not going to matter for when we do this. Okay, so I'm not going to be able to show you my graph and be able to write in that table. So I'm going to go ahead and just do everything here. We're underneath B. So the first thing it says is describe the transformation. So we all need to write that here. So I'm going through it slowly. I got h of x equals negative. Remember that negative is a reflection across the x-axis. The 2, it's not with the x, it's vertical. It's being multiplied, so it's going to be a stretch or a shrink. Since vertical does what it's supposed to, and it's a number greater than 1, it's going to be a vertical stretch by 2. The minus 3 is inside with x, so it's horizontal. It's being subtracted, so we know it's a shift. And a minus 3 is going to go to the right 3. And then we get that plus 4 at the end. It's not with the x, it's vertical. It's being added, so it's a shift. And it's a plus 4, so it's going to go up 4. Now, what is this going to do to my table? Well, let's look. So what's going to happen to my x's? Well, it says x minus 3, so we know we're going to add 3. So in that first column that's blank there, you're going to take all your x's and you're going to add 3. So like this first one, I would put negative 4 plus 3 equals, and it's negative 1. And then the next one, so I'm going to write that in my table here. And so our next one would be negative 2 plus 3, which is 1. Then we have negative 1 plus 3, which is 2. 1 plus 3 is 4. And 4 plus 3 is 7. So you should have all that written in that column. Now, what's going to happen to our y's? Well, it says negative 2 times on the outside, and it says plus 4. So we're going to take our y's times negative 2, and we're going to add 4. So we're going to do y times negative 2 plus 4. So for this first one, I'm going to use that y value, negative 2 times the negative 2 plus 4. Negative 2 times negative 2 is 4, plus 4 is 8. And so in this last column, if you're writing it as an ordered pair, you would write negative 1, 8. Or if you're going to set it up as a table, then you have negative 1, 8. Okay, I'm going to keep going. So our next y value was 3. 3 times negative 2 is negative 6, plus 4 is negative 2. The next y value was 0. So 0 times negative 2 is 0, plus 4 is 4. My next y value was 4 times negative 2 is negative 8, plus 4 is negative 4. And then my last y value there is 2 times negative 2 is negative 4, plus 4 is 0. And so write out your ordered pairs, or put it in a table there at the end, and then let's graph that. All right. Once you get it graphed, you're able to check, did it reflect across the x-axis? It did flip upside down. Is it a vertical stretch by 2? It does look more narrow. Did it move to the right 3? It definitely moved to the right. And is a vertical shift up? It did shift up. So there is our graph. All right, and with example 4, it's just more of the same, but now we're going to use the square root of x. And so we've got, it tells us to compare and contrast the graph of f of x equals square root of x with the following transformations. Consider changes to the domain in each case, sketch the parent and each function. So it wants us to put the parent function on each one of these. So I'm actually going to go ahead and do that first. All right, so my parent function, I'm going to write it up here as a square root of x, which remember we use 0, 1, 4, and 9. And so I'm going to go ahead and just put that on all 3 of these. And I can't fit the last one on there, that's okay. All right, for the first one, it wants us to compare and contrast the graphs. So we're going to talk about the reflections and the shifts and the translations and everything. And let's see what happened. So we got the negative, which we know is going to reflect across the x-axis. And we got the plus 2 at the end. It's not with the x, therefore we know it's vertical. It's being added or subtracted, so it's a shift. And it's a plus 2, so it's going to go up 2. Now when I go to build this table, there's nothing inside with x, so my x's aren't going to change. So I'm going to keep them the same. And then my y's, though, are being multiplied by -1, and then we're going to add 2. So I'm going to take those y values, starting with 0 times -1 is 0, plus 2 is 2. 1 times -1 is -1, plus 2 is 1. 2 times -1 is -2, plus 2 is 0. And 3 times -1 is -3, plus 2 is -1. And so let's graph those ordered pairs. And then check it. Did it reflect across the x-axis? Yes. And did it shift up 2? Well, that endpoint there shifted up 2. Now, what about my domain? Well, we can see it starts here at that endpoint when x is 0, and then it's going to the right to positive infinity. So it's 0 included to positive infinity. So for B, h of x equals the square root of -x. The only thing we have there is that negative inside, so this is going to reflect across the y-axis. And so what is that going to do to my table? Well, it's going to affect my x's, and it says -1 times x, so we're going to divide by -1. So we're going to take all of our x's and divide by -1. So 0 divided by -1 is 0. 1 divided by -1 is -1. 4 divided by -1 is -4. And 9 divided by -1 is -9. There's nothing that affects my y, so they're going to stay the same. And then we're going to graph them. And then check, did it reflect across the y-axis? It did. What is the domain of my new function? Now looking at my graph, that's my blue line. Well, I can see it keeps going to the left, so it's going to keep going to -infinity, and it goes all the way to 0, and then it stops. And it's equal to at the 0. Then for C. C has a negative in front, which is a reflection across the x-axis. And it's got that positive 2 inside. It's inside with x, so we know it's horizontal. being added or subtracted, so we know it's a shift. And a plus 2 is going to go to the left 2. So I go to build my table. For my x's, I see x plus 2, so we know we're going to subtract 2. So let's go and subtract 2 from all those x's. 0 minus 2, 1 minus 2, 4 minus 2, and 9 minus 2. My y's only have that negative on the outside, so we're just going to multiply them by negative 1. So 0 times negative 1, 1 times negative 1, 2 times negative 1, and 3 times negative 1. And then we're just going to plot our points. And then check it. Did we reflect across the x-axis? We did. And did we shift to the left 2? We did. So there is our graph.